Hi, I'm going to describe section 1.1, um, which has a few simple topics, and this is actually a review section, so you may already be very familiar with those topics. And I'm going to pull out some of the questions from the customized non-credit review for test 1, so it will be a good preparation for test 1 as well. The very first thing is about the relation, and the relation can actually be described as a set of ordered pairs. So I may have something like 12, 2. I'm just making up some numbers. Negative 2, 3, 4, 7, etc. Now, I may ask you the question whether this set represents a function or not. In that case, what you need to pay attention to the first component. If there's any repetition of the first component, then you know it is not going to be a function. The reason is, notice in this particular case, I could have my mapping diagram done, like the first components are listed as 12, negative 2, and 4. And the second components are 2, 3, and 7. So you know which one is mapping to which component. So if I ask you a question like f of 4, you can give me a unique answer. So that is true in this case for each ordered pair. But if I had a repetition, let me just change some of the numbers. And now, once I change the set of ordered pairs, now if my question is f of 4, you are not sure which one to answer. So it is no longer a unique answer. So I actually cannot say 4 equals 3 or 4 equals 7. So this does not represent a function anymore. Another way to find out whether it's a function or not, if you know how the basic shape of the graph is, then you can easily answer the question by doing a vertical line test. And this actually will be convenient once you get a review of next section, which is about graphs of basic functions. I will wait until I cover the section, but just to give you an example, let's say I have a graph something like this, and I'm asking you to determine whether it's a function or not. So you think about the vertical lines at every single point. If there's any part of the graph and it intersects at more than one point, then it will not be a function. In this case, it does pass the vertical line test, so it will be a function. Okay. When you are trying to determine whether it is a function or not, it can be described in many different ways. If you notice, I have already written down the different types. It can be expressed in set of ordered pairs, table, mapping as an equation, or a graph. So this, once you have an idea, you will be able to determine whether it's a function or not by revising the concept of vertical line test and whether the first component repeats or not. Now, when we talk about the function, we also think about domain and range. The domain is basically the set of all x's, or the first components, and the range is always described by the set of y's, or the second components. So if you look at the first question, it asks you find the domain, and all you need to do is look at the first component and come up with that set of those numbers. And 15, in this particular example, what you're seeing in question number 1 is 15, 18, 42, and 15 is repeating, so I'll leave that one, and then 46. And once you write down that one, the next question will be whether it's a function or not. And if you notice that the first component 42, not 42, 15 is repeating, so you know it will not be a function. Okay, so now let's move on to the second question. and it does ask you whether it's a graph of a function or not. So if you think about graphs, you immediately think about the vertical line test. So it fails the vertical line test, so it is not going to be a function. For the next one, which is y equals 5x minus 8, this can be done in two different ways. You can substitute some values for x, all different types of real numbers. You can think of positive, negative, 0, and if you can come up with a unique y, then you know it is going to be a function. Or since you know what the shape of this equation will be, it's a linear equation, so it will be a line, and this line can be easily represented by doing a graph. See, negative 8, so you know your y-intercept will be somewhere at negative 8, and if you go 5 units up and 1 over, so that will turn out to be a positive slope of 5. So if you think about the vertical line test again, it will pass that test. So definitely it is a function. Let's move on to a few more questions. It's again xy equals 4. So if you look at this particular question, it is an equation, and it is not written as y equals something. So your first task will be to write down whatever is given, and then next step will be to write it down as y equals something. So in this case it turns out to be 4 over x. And if you substitute different values, you know you will get a unique value. Of course, x cannot be 0, so that does not hurt anything, except that your domain will be every real number except 0. So if I ask you the question of domain in this particular question, your domain will turn out to be, see, you have to use the notation since you are going to answer the question in the system. You cannot write it down like all real numbers except 0. In this case, you have to use the notation. So it comes out to be negative infinity to 0 and not including 0. So I will use the parenthesis, closed parenthesis, and I'll use union, and then it's going to be my 0 to infinity. So that becomes my answer for the domain. Okay. Again, same idea for the range. If you try to find out what are the values you can get for y, you know you can get all different real numbers, positive, negative, but you will never be able to get a value of 0. So the range will also be the same type of answer. It will be negative infinity to 0, union 0 through infinity. And in this context, I would actually want to remind you about 3 different types of parentheses. The first one is something like this. The second one, you may have noticed that I use sometimes curly braces, and sometimes I'm using square brackets. So if I use the same numbers, let's say 4, 7 for each one of those types of parentheses or brackets, and I am going to describe what that means. Since I'm talking about the interval, I'm not talking about the ordered pair in this case. So when I have open and closed parentheses for 4 and 7, what it indicates, if you think about the number line, and this is your 0, and that's, let's say, 4, and this is your 7, what I'm saying is I'm talking about all the values between 4 and 7, but not including the endpoints. Okay. When I talk about the closed parenthesis, so I'm actually talking about this one. So what it means, it's all values between 4 and 7, including the endpoints. And when I say 4 and 7 within the curly braces, that indicates that it is no longer an interval. It is basically separate values discrete values. So instead of writing down something like x equals 4, x equals 7, I'm just putting it in a set form and it comes up as 4 and 7. So you now understand very well which of the three different types of parentheses or brackets will be used when you are describing an interval. So when you are answering a question, you must pay attention which one you are selecting, not just the numbers you are selecting correctly. Which one should it be? Should it be open and closed parentheses, or open and closed square brackets, or should it be of course when you are talking about the interval, so it's no longer going to be curly braces. And a lot of times if students are not paying attention, they choose that as an option, so that is totally wrong. Keep that in mind. Okay, for the question number 6, if you notice, this one gives you a graph and it asks you to find out f of some number, and in this particular case it asks you to find out f of -5. Okay, this is question number 6 I'm working on. And what it means is that from the graph you determine when x equals -5 what will be the value of y, which is, we always express y as f of x, right? So in this case what I'm asking is find out when x equals -5 what will be the value of y coordinate. That's all I'm asking. So to determine that, you need to look at the graph carefully. To do that, click on that lens icon next to the graph. That will enlarge the graph and you will be able to read the graph clearly. The first question asks you to find out f of -5, so look at -5. In this case 1, 2, 3, 4, 5, and your f of -5 turns out to be -1. Y coordinate turned out to be -1. And what is the domain? If you are looking for y domain, you have to, and it is, you see the solid circle at the end points, that means it is a closed interval. Okay, and in this case it comes out to be from -6 up to +6. So the domain comes out to be -6 to +6. For the range, I think that's the next question. No, the next question does tell you, yeah, it's range. So you are talking about the y values. So find out what are the y values you are getting. So the lowest y value you get is -1, and the highest value you get is that's 1, 2, 3, 4, 5. So your range can be between -1 and 5. And notice one thing, when I'm selecting, I am not selecting -1 and 5 with open and closed parentheses. Rather, I'm using the square brackets to describe that I'm selecting the endpoints. What is the set of all values for such that fx equals 5? So you have to find out the interval of x for which your y value is 5. So in this case, if you notice, it's an interval between, the 5 is right there. So you are actually looking for all the x values between this one and that one, and it turns out to be 5 and 6. So your interval will be, for the last question, is 5 and 6. Okay. Okay, let's move on to the next question and see if that is something we need to work at this time or not. Okay, here you are describing the function, whether it is increasing or decreasing. So in this case, when you are looking for an increasing part, you are trying to determine whether, when you are going from left to right, so basically when you are talking about x values going from left to right, whether y value